how are you?
I'm good. How are you?
I'm well, thank you. Where are you?
I'm here in Austin, Texas for South by Southwest is an annual event, a festival for music and startups, entrepreneurship. There's a couple of 3D printed construction companies you might be familiar with. How are you doing?
Well, today I'm doing very well. I'm in north of Rome, in a wonderful place called Porto Santo Stefano. It's a fisherman town, and I live here. And I'm working on 3D printing as always, unfortunately. It's becoming quite boring after 17 years so far.
So a huge reason I wanted to have you on, 17 years you mentioned, is a very long time, especially relative to 3D printed construction and the companies that are building projects today. Certainly all of the buildings I've been to are much younger than 17 years old. So I want to ask you, when you started the 3D printed, kind of a resurgence of 3D printed concrete. You're probably familiar with William Urshel, a very different concept than yours. Yours is more, he didn't use step files or STL files, so that wasn't really 3D printing. What file type did you use for your first prints with your machine?
Oh, yes, STL file as well. Has been the first specification because basically the technology that inspired the D-shaped 3D printing technology is the technology invented by Emanuel Sachs at the MIT. You may remember the powder bed 3D printer called Z Corp Corporation. And so at the time, and still today, the format into which import the file into our proprietary slicing software is an STL file. Of course, since then, in the way we treat the file imported and we slice it is a bit different from the others, because when you import the STL file in the normal 3D printing approach, you slice the three-dimensional file and you create let's say a trajectory, a plotting trajectory. So is a vectorial approach to
a step file.
Yes. In this case, I turn each slice into a bitmap and into a matrix of dots, black and white. The white are merely sand, and the dots black are droplets of, let's say, binder or so. So my approach is a raster printing, exactly identical to digital raster printing of a normal inkjet printer. So the main difference between my approach and the general approach is in terms of in robotic approach is raster printing rather than vectorial printing and plotting somehow.
So the first house that you printed it had a printed roof, right?
Yes. To be honest, I've never been proud of the first home I printed, despite it's the very first ever. And I tell you why. My idea of 3D printing was as a new instrument to implement the ideas of a new generation of architects. So a new instrument that is a robotic instrument for a new generation of architects moving toward an organic architecture. But when, and the very first structure I did, that I supposed to be a big building structure, but instead I was obliged to scale down the dimension because I didn't have the binder. the very first house has been purchased has been commissioned by a museum in Milan, La Triennale Museum. It's a quite iconic entity in Italy. It's like the MoMA in New York, just to figure out something. And when this was commissioned, the architect said, Mr. Dini, you claim to be the man who print houses. So if a house is like the kid's house, like a small house like this. And they said, okay, fine, let's do the very kid house design sketched like this, and was printed in one go, including the roof, of course.
Was that using a powder bed, or was that just typical extrusion?
No, unfortunately, it was a powder bed. That is a bloody, sweaty operation, because when we printed this home, this tiny home, only, I'm sorry, I speak in meters rather than feet, but was only, should be a house transportable on a truck. So the width was exactly the width of a truck, 2.40 meters. And the width, the length was about 4.5 meters or so a very tiny home. And we printed in Pisa in 2010 on a powder bed deposition process, and was really labor intensive, very tiring. And the problem, the real disaster, was that when we pulled the house to upload on the truck, a piece broke.
Oh no!
An angle, a corner, and was a disaster, because the client never paid. The first 3D printed home was never paid because they claim the supply. Is an incredible story.
That's unfortunate that one little chip or crack like that. I mean, half of the sculptures in the museum probably have a chip or a crack somewhere.
But what worse is that the Triennale Museum didn't make any publicity of this event, just very local. Just 3 or 4 journalists came and took some pictures. And after that, this tiny home was transported in the complete height of communication on a hill on the Apennine Mountains, and is still there on the Apennines close to Piacenza, and is still there in very bad conditions. Was completely abandoned by them. And so the story of the first 3D printed home passed almost under silent.
Well, you've moved on from homes. Now your concentration is more on the environment and kind of restoring some of the natural beauty in the world. You've done some work above land, and you're doing some work underseas now. Can you talk a little bit about your current passions?
Yeah, this is a completely different story. It's a story of joy and happiness and proudness. It's a story of making 3D printed artificial reefs. This morning, you asked me how it's going today. I forgot that I'm chatting night and day so far with a guy close to Halifax in Canada, for making lobster reefs, repopulation reefs for lobsters, to be exact. And I'm just out from a successful project for a 3D printed artificial reefs in Tenerife, in also another project in Hong Kong. I have made several projects in Monte Carlo, the Netherlands, in Denmark, actually. So this is our core business, because powder bed 3D printing, despite I conceived to print homes in 3D, and is still my dreamt achievement, is ideal for making these very fancy organic architectural shapes. And this is probably the best thing I ever did in my life.
If you're designing a custom home for a lobster, I guess some of the considerations you make are protection and safety, right? Where can they lay eggs?
But it's funny to understand about the lifestyles of lobster, because, for instance, what is funny is that they ask for a double exit, because the lobster, when they talk, they tend to go backward to retire. So they need an escape of the back. Mm-hmm. So you must always to interact with marine biologists to understand the lifestyle of a lobster rather than an octopus, or even of a grouper, or even about, let's say, oysters. The lifestyle of fish imply impact on the shape of the home for fish you are going to shape.
Mm-hmm. I had a feeling that you would take kind of an engineering approach and try to make the best home for the animals that you could. So I guess the question becomes, if you're designing a home custom for lobsters, if you make it so perfect and you can make so many of them, it could be better than a natural cave that they might be able to find at sea, where it would only have one opening, or maybe sized improperly where a larger fish could come attack them. What if the lobsters love your 3D printed home so much they're not willing to live in rocks anymore?
You know, we as human beings at the beginning used to live under the stars or in the trees. Then we came down, we went north, and we had to shelter into caves. And century by century, we started to build up shelters to fit our needs, like a chair, for instance. Chairs don't exist in nature, but there are some elements that looks like a chair. So every animal's trended to fix it, to search for comfort anyway. And if you understand what are the elements that drive the concept of comfort for a lobster, you surely make them happy. I experienced personally that fish, as we as women, as mankind, has a sense of aesthetic. We perceive beautiful something that has a geometric shape, because our brain compute. Our brain compute continuously. So every time we see an harmony of math behind, we perceive that as beautiful. And fish do the same. When they see a shelter that maybe has something on top, so you can shelter underneath, that is quite larger to allow the pinch to stay comfortable. And when you give them an element that is not rude but soft or smooth, of course, I experienced that in a few hours, there is a competition of fish that tend to go and shelter and grab the opportunity of sheltering themselves.
Do you scuba dive?
Yeah, I'm not a diver. I used to be a pretty good apneist. So the place where I live is by the sea, and I could reach quite easily 20 meters depth in apnea.
People watching might be wondering, like, why do these guys care about fish houses? But it's not just it's not about just making the lobsters happy. People need food to eat, and the animals that we're farming, it's not nearly as clean as in the natural ocean. So if you're creating these safe places where reefs are getting destroyed, so the natural habitats aren't necessarily as available for these animals as they were in the past, but you're creating habitats where they can live safely in the open sea, which is the healthiest way for an animal to live. And then fishermen can ultimately catch the increased population of fish, and that will increase the sustainability of the local human population by improving their food supply, despite the natural challenges the lobsters are facing otherwise.
The sea is an endless opportunity of building construction. is the most promising environment into which humans can apply their creativity. House for fish, there are endless extensions of land under the seawater that are perfect for fish repopulation, not necessarily throwing trains, autobus, bus, cars, and stuff like this. We have a problem of feeding of 7-8 billion people, and then it's just a matter of creating the conditions for them to multiplicate.
Mm-hmm.
And some environments, for instance, I was looking at Canada. Some environments are ideal for probably feeding trillions of lobster, but they just need the shelters. And this is a common problem in several places. Give a shelter to a fish and trust that you will get more biomasses for our feeding, for sure.
Have there been any studies done on the cost effectiveness of farming? I guess it's not farming, but providing these environments and increasing the fish population versus trying to farm on land or in enclosed environments?
There are several techniques in making homes for fish. All of them are valid. What is important is that are cost effective and environmentally friendly. And by my side, of course, I tend to sell 3D printed home for fish, but not necessarily is the most cost effective. Basically, I trend to couple and to make sustainable and valid the use of 3D printing applied to artificial reefs is the fact that you can create what I called artistic artificial reefs that are attractive not only for fish but also for divers. Yeah. So my approach is to invite people to go and enjoy a tour into an underwater museum of art somehow, and bring richness to the local populations of fishermen, because they fish tourists rather than fish. So this is the idea. The business.
It's not like a McDonald's beef farm designed to be as cost effective as possible. It's a part of the environment designed for people to enjoy. Like they would any other part of the ocean, it seems. The materials wise, how did you design the material to be optimal for the ocean environment?
The very first absolute rule in principle, really in principle, is in situ resource utilization, of course. Ideally, you have to collect the local sand, shape the sand, and turn it into a shape.
Okay. So it's very similar to the local sand that it rests on.
Yes, take the sand and shape it digitally, hopefully.
We're using lime?
Pardon?
Using lime, cement?
Ideally, the binder you might fabricate using local resources. For instance, if you have lime, or you can calcinate lime and get calcium oxide, and then by hydration, you can create a mass that becomes a stone. Geopolymers are another method to create a concrete. Here in Italy, has been very successful in the Roman age, a blend of volcanic cinders called pozzolanas and calcium oxide. Concrete, Portland cement. So anything that is relatively close to the close in terms of distance and also chemical and mineralogical composition are good for not to alterate with alien minerals a local environment. This is ethical, absolutely ethical. Of course, you have to pollute with some bits of elements for preserve the dissolution, but in principle, the golden rule is in situ resource utilization.
You have the Reef project, and that occupies a lot of your time now. Do you have other projects you're working on?
Yes, I do. I have some projects. One of those, probably the most important, I'm under non-disclosure agreement, but is in Saudi Arabia, and it's not about artificial reefs. I have another project for marine environment, but recycling foundry rejects, because we have a big steel plant factory in Italy, and that has a sub-products, slag products that in a certain way can be environmentally friendly. And I have about 3 or 4 projects mostly related to the sea environment. That is our core business, actually. Despite I'm still keen someday to print homes in 3D, and I'm doing something with Christian Pezza over there in US for revitalizing one project about land reclamation, and another project that hopefully will be implemented soon to revitalize the original project of printing homes in one go, from the foundation up to the roof, including stairs, balconies, bas reliefs, chimneys, Gaudi-like fancy shape, and the roof, using the D-shaped 3D printing technology in particle bedded 3D printing. So it means that you need a big 3D printer, big like the homes that you are going to print, capable to handle 1,000 cubic meters of aggregates. It's a challenging machine. Personally, I'd be ready to build it. I'm not, but more not for business, but to demonstrate to the world that the 3D printing, the real 3D printing, is still the shape, and because printing a house in one go, it's not just merely printing the walls, but it's printing everything in one go, and at a low cost. In principle, if we have had, and when we shall have the opportunity to print a home in 3D, I can challenge the fact that in say 100 hours, real 100 hours, not the 24 hours, that sounds like bullshit. In 100 hours, we can deliver let's say a 200 square meter building, on a 2-story building, at about $25,000, just the rough part of the building. But what most important, not a house, but a stunning, beautiful house, because beauty is not an optional for us. Beauty is the way living in a beautiful environment is good for the soul, is enhances self-improvement. Beauty should not be an optional in making a building. And that's why I invented this shape, to, let's say, democratize beauty, making it affordable for everyone.
So when you build that home, do you have any idea what continent it might be in?
Maybe US. I tried once, but has been a failure. Not my fault.
Build anywhere but California. It'll be much easier for you.
Yes. You know what? What is funny is that in Italy, you have to fight to find out, let's say, to raise money, say $100,000. With the same effort in California,
100 million.
I've never been able to succeed in that. In California, you can raise easily 10 millions for the same, with the same effort. And with the 10 millions, I might deliver not one home, but at least 3 or 5. And I tell you why. It's a matter of process. The reason why I invented this shape was not to print a home, but to print several homes continuously. Continuously, because the problem of the shape is that when you bring, say, 1,000 cubic meters of gravel and you print the home, and then you remove the unbound gravel or sand, you have, let's say, you leave over there 15% by weight. All the rest should be in principle brought back to the quarry. That is absolutely absurd. So the process of the shape is that you print a home here, then you move the printer aside, and you start to recycle to build the second home with the with the sand that you are evacuating for the first one, and so forth. So the first home require an enormous effort to bring on the building site 1,000 cubic meters of sand. But since the second, you started to recycle and to add what is missing. This is the way to print several homes, all different each other, of course. And this way, with let's say a 10 million project, we might deliver the 3D printer and at least 3 homes with stunning architectural features.
And then you can use the leftover sand or gravel for French drains or landscaping. There's all kinds of options with real estate construction, outdoor uses for gravel and sand. People love having elements like that.
Yes, what is important is the change of mindset in the perception of the ruling of the building construction codes, because you know, when you apply this technology, in principle you might, with stop and go, you might add reinforcement, but in the puristic approach of the shape, I print a pantheon, a Roman pantheon, a Roman style building that is load measuring building structure with very massive walls. Maybe California, that is a seismic zone, need a bit of momentum in shaping the house, because it's a seismic zone and masses play a big role. So probably we should stay low and wide rather than tall and straight. So
well,
you can
don't try to print in California. Every project in California never happens. People tell me all the time they want to do a project in California. They all never come to life because California is so challenging for construction. They have the most restrictive construction laws in the entire country by far. I mean, you can go to places in Texas, like an hour or two from Austin, big cities, and buy land that has no zoning restrictions.
No problem. I can come to Austin, Texas. No problem.
Yeah, raise money in California and then buy the land and build in Texas where you need no permits.
Talk with Christian Pezza, our common friend. Talk with him. I have the technology. I'm still in good health, so I'm still available to undertake the challenges. And I never been to Texas. I've been to California recently. Guest in Palm Springs. I don't know how far is it from Austin. And I've been guest of Jeff Bezos in an event he held in Palm Springs in 2016. I've been invited to make a demonstration, and Dan Brown was there, Ron Howard was there. It was a very honor for me, and I spent half an hour with Jeff Bezos talking about celebrating a friend that passed away when I was young, and was a man that reminded me Jeff, and I told him. So we had a moment of celebration of this dearest Wally.
Very nice. He sounds like a good guy when you talk about him.
Yes. I had a very good impression of Jeff. He's despite he's a multi-billionaire, when he listens, he really listens. He is completely focused on you. and everything is, he has the capability to focus on the task, whatever it is. And this was just for social. I was telling him a story. And I understood why he became so successful.
Did he come off as very intelligent?
Pardon?
When communicating with him, he seemed very intelligent, or he kind of seemed like an average guy?
Yeah, intelligence in the sense that he listened. He is an excellent listener. And when you listen, you're a lot ahead in understanding and in intelligence.
Do you think that he grasped your technology well?
No, he was. I was invited. I didn't understand at the beginning when I was invited there. I was invited by some guys in Rome. When I was there, I understood why I was there, because I was just like something to say, here we have the inventor of the printer of houses. And I suppose to go there to sell my technology, but it was not at all, it was not true. The reason was, the purpose was to promote the smallest printer in the world for iPhone 3D printer. There were $99.99 of the smallest 3D printer, but to market Jeff this, they used me. So I felt really used. But said that, was a real honor for me to be invited as a big thinker there. But the purpose or the scope of the demonstration in Palm Springs was just to print something. We had a shelter, a tent, and we placed the printer in under the tent, and we printed some items. The problem is that a desert storm forced us to stop everything, and we couldn't deliver the entire sculpture, but just small bits here and there. I might show you something if you want to. Might share my screen and show you.
Yeah, that'd be fine. I think I can. One participant. You should be able to share the screen now.
Yeah. Okay. Let me see.
But I think it's very honorable that you talk about the project and explain it didn't go all the way through. There was a desert storm. I mean, even just in the past couple of months, there are companies that I went to film who had failures during their prints, and they said, please don't put this online. Please don't show anybody. Please don't tell anybody. It's like, come on, be honest with the people so that they understand the realities of things happen. You're printing outside, you're exposed to the elements, just like any other construction. They want magic.
I will share my screen. It's a pleasure to show you have to enable the share screen
here.
So this is myself in Palm Springs while emptying and unveiling the sculpture. Here is the section of printing.
Wow.
You can see the environment in the back. Here is the vacuum, the dust evacuation.
Mm-hmm.
Here is the people. Here is one of the portion of the items we supposed to assemble to create a big sculpture. And about the video, here is, let me show if I...
Wow. So all of the little blue hoses on the left side, are those containing the liquid binder, or what is that, electrical?
Sorry?
They're all of the blue wires on the left side. There were like 100 or 1,000 blue wires on the left side.
Wow, the blue wire, these are the pipes for delivering the liquid to the nozzles.
The binding liquid?
The binding liquid, correct. So you see, this is more visible.
Yeah.
And
so
this machine is still working. Today, we are printing with this machine some artificial reefs that we shall deliver to Tenerife.
How long does the liquid take on the powder to become solid?
Since the deposit let's say in one night, they become, the minimum curing time is one night, one day, let's say.
And then the printer, go ahead.
And become, of course, you have to handle with care.
Fragile. So the printer puts the powder down as well after the wet layer. So it does dry layer, wet layer, dry, wet layer, wet layer.
Yeah, the process is continuous. You deposit a layer and you drop. You deposit a layer and each layer attached to the next one. So if this is in principle is a process that should not stop to avoid creating some discontinuity in the process and the layering.
Mm-hmm. And technically, is that a concrete?
Well, in this specific case, it's not. This is in this specific case, the chemistry, the substrate is a blend of sand, desert sand, of course, and magnesium oxide. And the liquid is a chlorine solution of magnesium. So what you get out of this process, in this specific process, is a sandstone that is not a concrete. But if you apply the same process using a mortar, a dry mortar, and water, you can get a concrete. Let's say a 3D printed mortar out of concrete. I can share with you something about a different process where we print concrete in 3D. For instance, these ones are out of concrete. This is digital concrete in real. These are in the Netherlands. These are for artificial reefs.
Did you do any kind of finishing to the exterior? Because there's no evidence of any kind of layer lines or anything. Are they sandblasted? Or?
Well, it depends. It depends. For instance, in this case, there is no finishing. This one, there is no finish. This is the texture is exactly how you get the texture. So in other cases, this is how the outcome is without any treatment. And in other cases, we apply some grinding, some to make the surface smoother. Depends by the purpose, the kind of how the machine is set. There are so many variables. For instance, this is made very smooth, but artificially. This is some pieces that we sent to Disney in Glendale, in California, and you can see some fiberglass for reinforcement. And this is a Rygo that we actually is in Seattle. This is a 3-color 3D printed series of benches for homes for this. And this is a sculpture, rings.
Wow.
Really endless. We made so many things. This is a piece of moon that we sent to New York. Crazy things, really. This is a bunker. This is we shoot with a cannon for bunker. This is another element. So this is just a miscellanea of elements.
The texture is very natural compared to other printed stone, or you don't see the layers. So you could come across an object like that and have to guess whether it's man-made or nature.
Yeah, very true, very true. It depends by the purposes. This is the home for fish in Monte Carlo. This is in Monte Carlo in Monaco. What else? I'm going randomly here and there. This is the project in Tenerife. This is another technology. that is very rough, but this is for printing using a different technology, absolutely super rough, you see.
Much larger aggregate size.
Yeah, but also instead of pouring water, we pour a slurry of cement, of Portland cement. So this is the kind of technology for Underwater Garden International. Let's go move forward. This is the kind of architecture that in principle should be printed not in California, but in Austin, Texas, let's say. So this is the kind of dreamt architecture that I never succeed to print out with in one go, of course.
I mean, just looking at that, that looks like a $10 million home by itself.
But you know what? In principle, with the right technology, with the right machine, this might cost the same of probably. Imagine that NASA decide to go on the moon and invest $1 billion. Okay, but let's say imagine that an investment of $10 million might bring this home to be delivered, all included, and with the 3D printer mortgaged for the next home that might cost a few tens of $1,000s. And I'm not joking, because I made some, I have some calculation, I don't know why this doesn't start. If you give me a while, I can search for something that, so we are moving toward a different matter, that is printing homes. So I have to focus a second on that, on this task, because I wasn't prepared to that.
Well, I'm very happy you're visiting your initial kind of pursuit of 3D printed homes. My channel is really dedicated to affordable housing and 3D printed houses. So I was always happy to have you on, even if you're only focused on Reefs, because of your work 17 years ago building the 3D printed home. But it's very nice for me to hear you're still focused on some housing, and that's still something you spend time with.
The reason why I'm chatting with you, Jared, is because Christian Pezza said, Enrico, you cannot give up right now. So I have to introduce you about my approach of printing homes. First of all, I might say, I have to show you something, otherwise you won't understand what I mean. Okay, fine. So let's start from the video that show the printing process of a small portion of a home, just printing one element.
Sure.
Just to let the people understand that we print the full section of a home in one go. What you see in the border is just the delimitation of the perimeter of the printing area. And here you see the section of one corner of the home.
Mm-hmm.
So one layer to print take about 6 minutes to print one layer, 1 centimeter thick of a building, 10 by 10 meter side. 6 minutes per centimeter. Okay.
Wow, that's very fast.
Yes, exactly.
And it seems you're printing inside of the structure of the home. Thinking about it, the only added cost to do something like that is the extra liquid, because you need that powder anyway. So you can really save a lot of money by doing 2 prints at once or multiple prints using the empty space.
Exactly. You print the section in one go with not one nozzle, but with 300 or 600. Here is our software, slicing software. Imagine these are the foundations. how looks like the printing of the section of the foundations, the pavement, the walls. Day by day, each section is each skip is about a half a day work. And this is the slicing software. And then I show you, these are 100 hours of work. And then I show you a video of an accelerated video of the layering process. It's not exactly the same building, is another shape.
So the printer you showed me before, the real printer, what were the dimensions in meters?
That printer is the one that we delivered to Mozambique for, let's say, what I call the camping printer is 4 meters by 3 meters. It's about 12 cubic meters. The one you see here is 10 meters by 10 meters or 12 by 12, but I never built such a big printer.
Yeah.
And wow. You see how might look like the 3D print, the home after the evacuation of the unbound aggregates. So you see that we print not only the walls, but also the stairs and also part of the furniture and also the bed. As you see, all of that might be printed with some bas reliefs. And all this process is done totally, entirely in a digital way. I go forward quickly. Let's talk about the cost of the process.
Sure. To build that larger printer, how much investment would it take to do that 12 meter by 12 meter larger printer?
Depending how far beyond we want to move. When people ask me, down here in this, I put €1.5 million for this printer.
Wow. That's not even for one single printer that size. That's not a crazy price.
No, especially if you consider that is the cost of the prototype. In principle, this printer that I priced €1.5 million might cost less than half than that.
Mm-hmm. Especially if you're making 4, 5, 10 units.
Of course, the scale. But this is just to imagine. Follow me in this analysis. What you see here is the scenario of printing one home that can be enveloped into a 10 meter by 10 meter by 8 meter envelope, bounding box. So we are talking about a building on two-story building, floor plus ground floor plus first floor. So we are talking about 800 cubic meters of building. And here is you have the density of the aggregates in tons per cubic meter. Mm-hmm. So we have to prepare for the first home something like 1,500 tons of innards. That is an enormous amount of aggregates. So that's why I'm saying doesn't make sense to make this enormous effort just to print one home. You have to go and be prepared to print, let's say, an entire neighborhood. And so here is the volume. of the real volume of the full part of the building, about 200 cubic meter. That is an estimation much over in excess, including the foundation. Here you have the column of the cost of the cement, 150 euros per metric ton, gravel, 10 euros per ton, water, labor, about 20 euros per hour. And then we have the pitch, printing pitch, that is 1 centimeters per layer. And according to the performance of the machine, here you see above the way the printing time of one layer is calculated. So namely, theoretically, if you don't have stops of the printer and you feed the machine continuously and properly without interruption, so there are not a bottleneck in the process, in principle, the printing time of the house is only 70 hours, with three people per shift, working on 3 shifts, on 4 shifts continuously. Of course, we don't consider maintenance and stops and go. And going to the cost, you see that the cost of the cement, the cost of gravel, water, bring the cost, the theoretical building cost at 16,000 euros only for a 200 square meter home at 83 euros per square meter, not considering the mortgage of the printer. And if we also consider the overheads and the mortgage time of 72 months for a 1.5 million euros printer, in principle, in theory, the first building structure, the building structure might cost 38,000 euros at 191 euros per square meter only.
Is 70 typical mortgage in Italy?
Usually in Italy, for such big, important equipment, the mortgage time is about 5 years.
Wow. In America, most houses have a 30-year mortgage.
Okay. We have what we call accelerated mortgage.
Yeah, I mean, it would look a lot cheaper on a 30-year.
Yeah, indeed. So this is how it works.
But the overhead percentage would be lower as well. Right now, you can get rates like 4%, but the numbers. So this is all of the concrete, which includes not only the walls but also a lot of the furniture, a lot of the finishing details like balconies and such. But it doesn't include.
No. This is just the cost of the rough structure, just the cement, water. Then depending the kind of furniture, you can go low profile, high profile. This is usually in Italy, the cost of a home, entire home, let's say a turnkey home, is depending is the lowest. I know people that can offer you a turnkey home at only $1,250 per square meter. That is very cheap. Mm-hmm. Usually in Italy, the cost of the raw building is about between 25 and 30% of the whole cost of the building. Mm-hmm. So imagine that. Usually we are talking about 500 and 750 euros per square meter just for the rough structure. Now, even in the lowest scenario of the lowest construction cost of 250 euros per square meter, we are at 191, that is already below the threshold of the lowest of the construction cost of a building.
This isn't turnkey. This still needs electrical, plumbing.
Yes, of course, you need plumbing and so forth. What is nice is this, in this case, because you print the building in one go, you can foresee into the printing file all the tracks to facilitate the plumbing. I want to show you another document with you,
Please.
Jared. Is about the design process. Is an algorithmic process. Is an excellent work made by Paolo Carboni, who made this final thesis. Here you see. Okay. Here you see, I'm going to from the beginning. Okay, I'm going up to see. Okay, here is how the process flow. We start from the ground preparation, then we deploy the printer, then we assemble the printer, and then we prepare the foundations.
What's the approximate assembly time?
Pardon?
How long does it take to assemble?
Between 1 day and 7 days. Probably will be, we are in the middle, 4 or 5 days to assemble to be operative. And then we start with the first layer number 1. And then we start printing, and let's say from layer 1 to 1400, we can proceed at about half a meter per day. Let's say half a meter per day. It's a reasonable time, printing time. Mm-hmm. Between, hopefully, might be even 1 meter per day. But basically at the end, this is the crucial moment, that is moving the printer aside. What means moving the printer aside? It means that the printer is on wheels, is on a sort of a gigantic gantry on wheels. So you move the printer away, and you start immediately to print the next building. The next building, recycling the sand. So meanwhile you are printing the new building, you use the surface of the surface of the sand as a scaffolding to start plastering the roof, and so you can work in full safety, and at the end you can finally you have to add what is missing in terms of aggregates, and so this is the scenario of printing.
Very fascinating. And moving the printer, obviously, on wheels is going to be so much easier than having to disassemble and reassemble it. When you say it takes 1 to 7 days to assemble the printer, I imagine you haven't had to disassemble and assemble it. So how many times have you done that?
Well, I did once. The very first time I did this, I show you something. I have made several tens of presentation in my life, but if I go super back in my story, the very first time that I attempted to go on the building site and let me search for an historical slide.
I've been doing this for 2 years. I've been doing this for 2 years, and it's difficult for me to find all of my files and everything. I can't imagine how challenging after 17 years the collection of files must get to organize.
Yeah. However, this is one of the several presentation I gave. Okay. Those are, let's say, here it is. This is the experiment of assembling the 3D printer on site. Mm-hmm. This is a very historical picture, because this has been, I gave these presentations since 2007. The first presentation I gave was in Eindhoven in the Netherlands. And that's why in the Netherlands is so active on 3D printing. Mm-hmm. And I show this printer as a concept. If you want to print a home, you go on a building site with a truck and you assemble the printer. Unfortunately, I didn't have the binder because the company that obliged me to bring the printer on site beside their factory never provided the binder to me. So I had to shelter and to go indoor to print a scaled version of the object that I wanted to print. Mm-hmm. So you see the printer, but it's indoor because I had to move. And this experiment I've done of going on a building site and assembling the printer in a few hours has been done also for a recent project I did for the National Army. If I go to the National Plan of Military Research, when we printed a bunker, let me search if I find out the right. This is the phase 2, and this is the technical report of this military research we did in 2016. I will show you how it works. This is the National Plan of Military Research. Sorry, is in Italian. So this is the story about how the shelter are usually done according to NATO treat. This is all the story about how to stop the threat of a bullet. Mm-hmm. And blah blah blah. This is the story about several items. But at the end, I'm searching for the right slide. This is the home 3D printed. You may remember when I mentioned about the 3D printed home, and then this is the experience of making an on-site experiment of printing with the generator, blah blah blah. So
you don't need a mixer pump system.
Pardon?
You don't need a mixer pump system for your apparatus.
Well, no, in the sense that you need just a pot filled with water with a certain amount of water. You see, here is there is a pressure, there is a tank, as you see in this schematic, with some nozzles, but basically it's just a reservoir that feed the water almost at atmospheric pressure.
And so you're feeding water in from both sides to get equal pressure?
Exactly, you're right. This is the layout, exactly. And I'm searching for I was searching for the scenario of when we made the shelter. Just a second. I'm searching for the right picture.
Take your time.
Here it is. Okay, here you see, this has been made in Nettuno. In Nettuno, we brought the printer, we assembled the printer, and since the beginning to the end, it took about 4 hours. And then we started printing with the calibration, and then we printed the bunker in 3D, and then we went to shoot it's been very laborious.
We won't get in trouble for showing these military projects.
I don't care, because you know what? After that, the US officials was aware about that, and they applied that also in the US on a much bigger scale, much bigger scale. So this is how it works. It's how the story flow.
I saw they have like a huge gun that was like a 50 caliber. There's a company in America that shot a tiny little pistol at their 3D printed wall, but that's a serious test they're doing there.
No, we shoot with a 25 millimeters armor discharge piercing sabot, very high speed projectile, and we stopped the threat because I applied some concept that I cannot disclosure in this case. So the very core of how we stop the bullet, I cannot disclosure. But just to mean that, back to your question, did you try to make this experience of printing on site? Yes, 2 or 3 times, but the big picture is still missing about must be done much more than we have done in these 17 years. What is missing is printing homes in 3D, eventually in Austin, Texas, because we in Italy, I never succeed to do much more than making a small tiny house, a tiny home, like the one you see that is in the nowhere. Probably, I think that the same experience as I did here in Italy, done in Italy, probably would be made an enormous noise or worldwide. I'm pretty confident of that. But again, this is something still possible. And that's why it's been a pleasure for me to share with you the full picture, because apart of the moon, of course, because something is still missing in the D-Shape project. Is the project of printing big elements, big building components, or even let's say printing homes with amazing features on site.
Absolutely. And so if people who are listening are interested in either pursuing a project, maybe they want you to build a home for them, or maybe they want to invest and help you build a printer, what are you looking for? How can people help you? And what's the best way for them to get in touch with you?
Well, as I always said, I think that any investor that any brave investor that says, Mr. Dini, what you have done, it's more than enough to demonstrate that you are a smart man with a clear vision, the man who really, I'm the good father of 3D printing worldwide because my work inspired everyone. I'm not good as an entrepreneur, as good as an inventor, I admit. But again, the size of a project like this is about $10 million, and are enough to deliver not 1 but at least 3 prototype buildings. So anybody that is interested to say, Mr. Dini, I'm willing to invest in your project for printing homes, because I have to split by artificial reefs because they are completely different. So is open the call for brave entrepreneurs, of brave contractors who says, this is Mr. Dini, the land, these are the working capital that give you the possibility to do what you have in mind, and I'm open to offer shares in Monolith UK Limited in return, up to, let's say, 15%, 20%, 30% shares, depending the amount of investment and the proposal. So this is the pitch, basically. The first milestone that is under the risk of the entrepreneur. That's why I'm talking about brave entrepreneurs. So won't be a failure at all. The matter is the delivery time that might be 1 year, might be 1.5 years, might be 2 years, or the time scale is about, let's say, between 24 and 48 months. The investment scale is between 2.5 and 10 millions, and this is what I propose to anybody that is interested. I give as a free for free let's say if people is interested only to one market and to set a company in the US or to get a license for this, that is even better for me, because I don't want to be involved in companies here and there, because I'm too aged somehow. I'm ready to give a license for the United States of America for let's say for 25 years to anybody that is willing to make this test. So I offer full right of exploitation of the D-shaped technology in the US, with the full providing of the technology to the best offer on the table coming from the US.
Well, you've been very honest and transparent, and I really appreciate that, because it's not. I don't have
any problem.
It's not something I'm used to. Most of the companies in this industry, as I'm sure you've seen it, are claiming 20-hour print, 12-hour print. They did it for $10,000, $5,000, whatever the cost is. They don't ever want to talk about the issues. They like to say, oh, you just press play on your phone and then the house is built and you're ready to move in. You can live there with your family. And those are the companies that end up raising so much money, but they're raising the money from people who maybe aren't doing so much research. And so it's harder for them to I don't know, accept the claims. But for me, I'm not a big investor, but the honesty that you're demonstrating is very important in terms of people will understand what to expect, and they'll end up with something much closer to what they expect, versus if they're misled and they're fed false promises, it just leads to disappointment. So I think you're taking a very honorable path. It's not an easy path, but I would love to see within the next few years, 5 years, 10 years, you raise a lot of money and that come to America, print a building, I'll come visit. Maybe you're in Italy. In 2023, I plan on shipping my car to Europe for 6 months so I can properly visit all the companies there. So hopefully then this time next year, maybe I can come visit you and maybe we'll go clean up the house on the hill or something.
I guess that if you come with the car, you will be my guest here in Porto Stefano. More likely, I'm confident that the first 3D printed house with the D-shape process might happen over there in Austin, Texas. Because I'm pretty confident that Christian, you will be able to deliver this message to whom I might be interested, really to make US sent a rocket to the moon and brought back the people. Kennedy said,
depends who you ask.
Let's go on the moon and bring back. Okay, we are not in that order of magnitude, to be honest. But I still have to see a real 3D printed home as I imagined it 17 years ago. And I, not without fake modesty, I believe to be the only man on the planet capable to deliver that, because I know what to do.
Well, I really appreciate you taking the time to have this call with me today and illuminate some of the realities of D-Shape. You definitely have a very unique technology, unique product. I saw at the end you showed the patent that you have. That's another unique thing that's good for investors. A lot of the other companies use technology too similar to the William Urshel build, so they can't get patents on their technology, whereas having a patent gives you protection, gives investors protection. So it'll be very exciting to see what comes in the next month, the next years, and I'm very happy to have made your acquaintance. Hopefully we can either do this in person again in Italy, or we'll do another Zoom call depending on the world's circumstances. And thanks again. This was fantastic.
Thanks, Jared. It has been a pleasure, and have a nice day. Hello to all your listeners.
You as well.
Ciao.
Stay in touch.